What is a sequence? So I put a bunch of definitions on here for you. Don't have to memorize them, but at least they're kind of in your unit packet. So what is a sequence? A sequence is just a pattern. So sometimes I have students add that a sequence is just a pattern. Because for some reason, remembering the word pattern is easier than just a function whose domain is the set of positive integers. Sometimes it's easier to just say that a sequence is a pattern. It is important, this idea of this domain, so I'll keep putting that up, but a sequence is represented by just listing its values in order. That's what I was doing over here, just listing things in order. And a sub n notation, this is a new notation, it's going to help us distinguish between a function and a sequence. So here is the same operation written as a function, y equals or f of x equals 3x minus 2, or a sub n equals 3n minus 2. It's the same thing, multiply by 3 and subtract 2. But the first one has the domain of all row numbers. So I could plug in -5. I could plug in 1.5. In this one, I'm only allowed to plug in 1, 2, 3, 4, because that's term 1, term 2. So there is a big difference based on how it is written. So you're going to see that a sub n notation. So it says I can evaluate f of 1.5, meaning plug in 1.5, but I can't evaluate a sub 1.5, which means plug in 1.5. So here's an example. If you have something that says a sub n, that's like y equals 3 times n. If you have to generate the first 3 terms of the sequence, you're going to plug in 1 and see what you get. Then you're going to plug in when n is 2. N just means what term you're on. So this is the first term, the second term, and the third term. So you're going to plug in 1, plug in 2, and plug in 3 and see what you get. So on today's work, mostly what we're doing is generating the sequence from the equation. So if I plug in 1, you want to write 3 times 1 would just be 3. 3 times 2 would just be 6. And 3 times 3 would just be 9. So this is my sequence, 3, 6, 9. Here's another example. A sub n equals 5 plus 3 times n minus 1. Looks a little bit confusing, but we're going to see this notation over and over again for an arithmetic sequence coming up. You're going to use this formula, which is y equals, to plug in 7. You always plug it in on the right-hand side of an equation, right? So it's like plugging in 7 for x. We're plugging in 7 for n, and we're going to see what we get. Over here, we're going to plug in 10. Plug in 10 for n and see what you get. So if I plug in 7, let's see, what would I get? I'm going to write it kind of below here since I work. Already here, 5 plus 3 times 7 minus 1. So now I need to do the math. Let's see. Order of operations is important. So let's see, 7 minus 1 is 6. And 3 times 6 would come next. That would be 18. So I really need to do 5 plus 18 for order of operations. So my final answer would be 23. Does that sound right? Make sure I didn't make a mental math error. 5 plus 18 is 23, right? Now you plug in 10 and you see what you get when you plug in 10. So it's really back to like linear functions and plugging numbers in. It's just the notation that's different. So try plugging in 10 and seeing what you get. Maybe some of you will like this unit. Total fresh start from anything we've done this year, really. Kind of a little 10-day mini unit. So let's see, if I plug in 10, I would get 5 plus 3 times, 3 times 9 is 27. So 5 plus 27 is what, 32? Did everyone get 32? So some mental math, plugging things in, order of operations. All right, and then here's another one. This time I've got -1 to the nth power. That's going to make me go kind of negative positive or positive negative, because when you square -1, it's positive, but when you cube -1, it's negative. So let's see, they want you to find the first 3 terms. So this time they didn't tell you what to plug in. You need to know to get the first term, I plug in the number 1. So I would take 3 and I would add just -1, right? Because -1 to the first is -1. So 3 plus -1 would just be 2. So now I need to plug in the number 2, but I'm squaring a negative number now. So when I square a negative, it's in parentheses, I get +1, and I'm adding 3, so I would get 4. And then what happens when I do the next term? Now I'm plugging in an odd power, so this goes back to be a -1 plus 3. So I go from 2 to 4 to 2 to 4 to 2 to 4. So does that kind of make sense how you could alternate adding and subtracting 1? So that's it. If you can master plugging in n, you've basically mastered the first step of a sequence. Can you generate the terms of a sequence? The terms are just an ordered list, and we already kind of talked about this, but a sub 7 means find the 7th term. So this says, given this sequence, so here's a pattern. What if I asked you, what is a sub 4 in this pattern? What would you say? 8. So we're just getting kind of fluent with like the vocabulary, right? This is a sequence. Find a sub 4. I just go to the 4th term and the answer is 8. All right, so when you get to pre-calculus, those of you that might take pre-calculus, this matters a little bit more if something is infinite or finite. I just wanted to introduce you to vocabulary. We're not going to interact with this much, but if this goes ... that means it goes on forever. And if it's in a set of brackets, that means that it stops. So when you get to study series in pre-calculus, you're going to be adding up the terms of a sequence. So if you wanted to add up all the rows in an auditorium, that's finite, right? There's only 20 rows. So I only have to add up the 20 rows. If it went on forever, could you actually add it up? No, if there's always one more row, you can never add them all together because it would diverge to infinity. So I really put this in there just for introduction's sake. There's no real problems we're going to do that involve infinite or finite. All right, but graphing is important because I want you to compare it to the graph of a function. So it says when graphing terms of a sequence, the point should be discrete. And I know we've used the word discrete this year as the opposite of continuous, but we've never actually had a discrete situation before. This is the first time that you have something that is discrete. So when you plot the points of a sequence, they don't get connected. They just look like that. That's why in Unit 1, when you guys weren't connecting your dots to make a line, I was saying, please make sure that you connect the dots because every single point on here is part of this function. This time, we're not going to connect them. So it says generate the first 4 terms and then use the points to graph the sequence. So let's first generate what are my first 4 terms of this sequence. When I plug in 1, what do I get? Let's see, 2 minus 1 would give me 1. I just like to write the little numbers down here so that I know what am I plugging in. I'm plugging in 2, I'm plugging in 3, I'm plugging in 4. So go ahead and generate those 4 terms, and then I'll show you how we're going to graph them. A lot of plug and chug. That's all it is. Not a whole lot to memorize, but once you can read the notation, it should feel pretty easy, like Algebra 1 almost. Let's see, if I plug in 2, I would get 3. If I plug in 3, I get 5. And if I plug in 4, 8 minus 1, I get 7. How do I graph that? So that's really just the set of points 1, 1, 2, 3, 3, 5, and 4, 7. So the n value is like x, and the output of the sequence is kind of like the y value. So you're going to graph those 4 dots and then just leave them as dots. So you're graphing a sequence. So 1, 1, 2, 3, 3, 5, and 4, 7. Looks like that. What type of function do you think that is? Looks linear to me. So you can still identify linear, exponential, quadratic based on what the shape is. All right, I think you got that so far. So we can generate terms and we know how to graph a sequence. And so this is kind of all your vocabulary kind of all in one place. We're going to use these terms a lot. Closed, which some of your worksheets say explicit. I always say closed. Closed versus recursive. So you treat them a little bit differently, so that's why it's important that you know. If you have a closed formula, that's what we have on the front page. They allow direct computation of any term in the sequence. It works like a function, just plug in n. So that's what we did on the whole front page. We were plugging in n every time. So let's do one more. Plug in 4 and see what you get. Because I want to compare that with a recursive form. I think you will like closed and you might not like recursive. So if I plug in 4, 7 times 4 plus 1 comes out to how much? 29, right? 7 times 4 is 28. Plus 1 is 29. So that's closed. Recursive is different. Recursive is a formula in which each term is only defined as a function of the preceding term. I can't just throw in the number 100. So I would have to find term 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 99 to get to 100. So it's really not ideal for computing these higher numbers, but it's the only way that you can represent the Fibonacci sequence. There's other sequences too, but the Fibonacci sequence in nature is really famous. There's no way that you can get this term without first finding all of these terms. There's no formula that you can write. It's not linear, it's not quadratic. So I can't figure this out. I would have to say that, okay, this gives me 13, this gives me 21, this gives me what, 34. Am I doing my math right? Tell me if I mess up. This would be what, 56? So this term is now 90. Does that sound right? Did I mess something up? Oh, this is 55. Thank you. So that makes this 89 now. Is that what it is? So I couldn't figure this out. I had to literally find all the terms that come before it. That's recursive. So it's like reverting back, like you're reverting back to the one that comes before it, recursive. All right, so here's some examples. And it's written differently. They use a sub k, and they usually have to give you like the first term of the sequence. See how they say a sub 1 equals 10? You're not plugging anything into this formula. So the way you read a recursive formula is you say, how do I get the term I want, right? A sub k. Let's say a sub k is 13. I take the term that comes before it. So that would be like the 12th term. And this said, whatever it is, you're going to add 3 to what you get. So if I'm starting at 10, I have to find the second, third, fourth, fifth to get a sub 6. So there's no other way to do this problem. So if I'm starting at the number 10 and I want to get this term, this says go to the previous term, right? So go to the previous term, and now I'm here, and do what to it? Add 3. So I'm going to add 3 to get to this term. So it's a pattern of adding 3 every time. So the only way I can get to the 6th term is by adding 3 to the previous term. So I would get 16, then I would get 19, then I would get 22. So then when I add 3, it looks like I would end at 25. Does that sound right? Add 3, add 3, add 3, add 3, add 3. There is a way that you could represent it not recursively, but I didn't give you that. It does say which type of sequence, closed or recursive, would you want to use to find the 100th term? You'd want to use the closed because you can plug in 100 directly. So you definitely want to use closed when you can. Here's the Fibonacci sequence that I was telling you about. What's the pattern? We already talked about the pattern. You're adding the two previous terms. So 1 plus 1 is what you get to get 2. 1 plus 2 you add to get 3. So what would be the next 4 terms in the pattern? We already kind of did this, but 5 plus 8, right, gives you 13. 8 plus 13 gives you 21, then 34, then 55. And it says, how would this be written using A sub k notation? You don't know how to write this just yet, so we're just going to write it. You take the term that you want to get. How do you find it? You go to the term that comes before it, right? So if this is term 8, I go to term 7. But I have to add the term that comes 2 before it. So if this was an 8, A sub 8, I would take A sub 7 and I would add A sub 6. I'm not plugging it into the formula though. I'm just going backwards and saying, I want to grab these 2 terms, add them together, and that will give me the next term. For recursive, you have to tell the person what you want to use as the first term, and in this case, you need the second term too. So I need to tell the person the first term is 1, the second term is 2, then they can add those together to get the third term. Then they can add the second and the third term to get the third term, or second and third to get the fourth term. So recursive is the hardest. We'll do the most practice on it because it takes a little bit to wrap your brain around it. So here's another way of kind of writing. This is the same sequence, right? A sub k equals A sub k minus 1 plus A sub k minus 2. What's the only difference? Their first term and their second term are different numbers. So you're going to do this same pattern. You're just going to start with 2 different numbers as your starting values. So it's not the Fibonacci sequence, but it's behaving like the Fibonacci sequence. So what would be term number 3? What would I get for term number 3? 28. You're just adding the 2 previous terms together to get the next term. What would be the next term? 48. Can you try the next 2 on your own? So 28, then 48. Not too bad once you figure out, just add the 2 preceding terms. Anyone need a calculator? 28 plus 48. My curse of brain on this. This pink calculator is in this class, right? You guys have one to try on 28 plus 48? All right. Do you need one? Calculator? Oh, there's one back here. You have one? You need one, Michael? Oh, you got one, Duncan? Oh, what was that? The resource page. Oh, perfect. Is this? Oh, one of these is Duncan? Oh, no, that's your new one. Okay, that's yours. Let me write that down. Okay. Now I lost my calculator. Oh, I brought this one home, and it's the sticky key one. Ugh, I don't even know how that one made it back. So let's see, 28 plus 48 should have come out to what? 76. And then 76 plus 48 should have come out to 124. Did you get those? Just make sure your resources are the same. So Michael, I checked off here. Okay, so that's kind of the facts about intro to sequences. I'd like you to take some time now and try page 501. So this is kind of like the first 3 questions on your quiz on Friday, right? Generating terms of a sequence, identifying the pattern. Maybe I might ask you, what's the difference between a sequence and a function? We'll write those on the board again tomorrow so that you remember the differences. But this is just listing the terms. Remember, you just have to plug in 1, plug in 2, plug in 3, plug in 4. These are a little bit harder. These are recursive. So if you need some help when you get down here, so 1 through 4 again, let me know. And then this is listing the 4 terms and graphing it, just like we did in the notes. The back page, these are a little bit more challenging sequences. So these wouldn't be really on your quiz on Friday, but some of you need to get a little bit pushed in your mathematical reasoning. And then just here's a couple others. Find the next three terms, write a recursive formula. So I think you should be able to do those about 16 problems, and then we can kind of come around and I can put up the answers. And this is what homework